Your car is valued at $20,000. How much is your car worth after 5 years if it is decreasing in value at a rate of 6.5% per year? All right, stop right there and think. Did they give you a percent? Yes. We're using this formula. Let's write it. Do I have to write the formula every time? It doesn't hurt. It'll help you memorize it if you write it every time. And also, it's good to have that structure so you'll know where to plug what. So what I like to do at this point is switch colors completely, come off to the side and start writing down what I know. And I'm going to use, let's use purple. Your car is valued at $20,000. That's the amount that my car is worth. That is not the amount after time has elapsed. That would be A. This is going to be P. So P is $20,000. How much is your car worth? I like to kind of stop and ask, oh, wait, what is that really asking? Well, they're asking, what is the amount after time has elapsed? How much time? 5 years. And it is decreasing. That word is important. Okay, so a minute ago in a previous video, I said, it was a minute ago when I recorded it, but previous video I said you get to pick plus or minus. We're going to pick a minus on this case because your car is not going to be increasing in value most of the time unless you have a classic car or something like that. The rate is 6.5% per year, so you could just come over here and say, well, R is 6.5%, and that's great, but I'm going to divide by 100, shortcut, move the decimal 2 places to the left, so the rate is really 0.065. Let's put a 0 in the front. And that means I'm ready to plug numbers in the correct place on this one. So A equals P. I know what P is. 1 minus. Okay, let's talk about that 1 for just a moment. That 1 is basically saying, okay, well, 100% minus 6.5%. That's what the 1 is. The 1 is built into the formula, because year after year, we're going to maintain 100% of our car minus 6.5% of our car. And then the next year, we're going to have 100% of our car minus 6.5%. That's what that's for. Or if it was increasing, we'd have 100% plus 6.5%. And then T is the number of years. Now, I'm asked to find out how long, not how long, but how much is your car worth. So they're asking us to find A. A is already by itself on this equation. So we're looking for the A. It's solved. There is no solving. All the stuff we did up at the top, not needed for this problem. Not at all, not for this context. Type it exactly the way it looks in Desmos. You don't need A equals. Just type this. So 20,000, 1 minus 0.065 to the 5. And we're dealing with money here. So normally I'm like, hey, let's use 3 decimal places. We could round to the nearest cent, which isn't very practical for a car. Like if I said, how much is your car worth? You wouldn't say $14,291.84. Like 84 cents, who cares? You can find that much money behind the cushions, right? I'm gonna put that, but they would probably say, oh, 14,300. They may round to the nearest $100. Or they might just say 14,291 or 14,290. They didn't say where to round. Generally, when they don't tell you where to round and it's money, let's use 2 decimal places because it makes, joke coming, it makes sense. 14,291.84. Okay, now things change. Your car was valued at $20,000. That's the original amount. Man, let's just go ahead and start writing. So P equals 20,000. But now it's worth 10. Oh, that is the amount after time has elapsed. Put commas if you want to. If it has been decreasing in value at a rate of 6.5% per year, so my rate is 6.5%. Oh, that was a waste of time. Let's move the decimal 2 places to the left. There we go. How many years did it take? Oh, now we don't have 5 years. Now they didn't tell us how many years. That's what they're asking. So this is going to involve, well, some skills that we gained up here at the top. So let's jump in. Never hurts to write the equation one more time. So let's write the equation one more time. A equals P, 1 plus or minus R to the T. And we're going to plug in everything we know. We know that A is 10,000. We know that P is 20,000. We have 1 minus 0.065, and we're going to raise it to the what? Don't know. Call it T. Okay, I would love to just skip a whole bunch of steps and jump to the very next line. If I did that, people might beat me up when they see me, or they beat me up in the comments that are currently disabled. So I'm going to show some unnecessary steps. It's not unnecessary, but once you get the hang of it, you'll be like, oh, 10,000 divided by 20,000, that would be a half. So a half equals, and then 1 minus 0.065. So you're going to do, basically, like if you had 100% and you subtracted 6.5%, you would have 93.5%. So 93.5%, 0.0935. If you need to type that in the calculator, feel free, but that is what it is. We're going to raise that to the t. Okay. Now, at this point, we have something that is truly exponential. All right, we've kind of gotten out of the realm of interpreting a word problem, and now we're up to this problem where we're like, oh, well, I've got to solve an exponential equation. So log, you know where the numbers go, right? It's a little backwards, but that's okay. Don't make your paper go sideways for it. Log base 0.935 of 0.5 equals t. Okay, let's start type. 0.935, 0.5, and this is going to equal time. What is time? Well, they are talking in terms of years, so my final answer is going to be, well, years. And they didn't ask to the nearest what. I'm going to use 3 decimal places, which isn't very practical for years, but why not? 10.313 years equals t. That's how long it takes for the car to depreciate from 20 to 10, to lose half its value, basically. Okay, now things get a little bit tricky. A culture of 1,500 bacteria is growing at a rate of 6.3%. Oh, they gave me a percent. How nice for them. So far, we've just been staying in this territory. We haven't gone over here. So let's start writing. The original amount is 1,500. Growing, good to know, at a rate of 6.3%. And that is 0.063. And it's every 12 hours. Now, I'm tempted to be like, oh, t equals 12 hours. Yeah, no. How many will there be after 7 days? T equals 7 days. No. Okay, I'm about to write something and you're going to get crazy about it, but hang with me. What in the world? Okay, if something happens every 12 hours, it happens 2 times for every day, every 24-hour period. Well, it happened 2 times every day for 7 days. So this is 14. I would say, well, I would try to figure out what the units are. And the units actually are going to be 14, 12-hour periods. It's a little clunky to word it that way, so I don't have to write that every time. But 14 12-hour periods, basically 14 times that this bacteria grew 6.3%. So let's write the original formula. P, 1 plus or minus r to the t. And then, oh, how many will there be? That's what they don't know, and that's the amount after time has elapsed. So there's your question right there. Put that or not, that's up to you. All this is optional, really. It's just a good way to organize your thoughts. So 1,500. 1 plus, because it's growing, 0.063. And we're going to raise it to the 14. The tricky part about this problem was interpreting where that 14 comes from. All right, 1,500, 1.063. Well, I put the plus when you can add in your head. Not divided, sorry. Raise that to the 14. By the way, we would love to solve. And look at that solving, it's great. We were solving for a variable that was way over here and it had some stuff around it, but now I'm solving for A. A is by itself. Just simply type this in, not the A, just that. I had students in the past that would just type that whole thing. Like, why did you do that? All you need is this right here. And that is what A is. So there you go. 3, 5, 2, 8. Didn't tell you where to round, but let's be real honest. Bacteria comes in whole numbers. You wouldn't be like, look at that half a bacteria. I mean, you could if you were talking about how it's in the middle of cell division or something. But there we go. 3,528 bacteria.